let's talk about the importance of knowing normally open and normally closed contacts in the controls automation world. So here's a picture above. So you see two examples. You have a normally open contact, normally closed. What does this mean to a controls person? So I definitely deal with this on the SCADA side when you're setting up an alarm. So if a contact is normally closed, which means it's in this closed position, it's naturally going to be, its initial position is going to be at a logic 1. It's in a closed status, so there's probably a voltage there. So in the SCADA world, if you are setting up an alarm on a normally closed contact, you have to remember if the contact is normally closed, that means your true condition is the initial condition. Now, when the whatever that sensor is tied to, when that triggers, this normally closed contact opens up and that voltage goes away. So with your PLC or SCADA system, now it needs to trigger the alarm on the false status, because now it's at a logic 0. And same thing for the opposite. For a normally open contact, in its initial state, it's at a logic 0. It's in a false status. When the alarm activates, it activates on a true status, right, in your SCADA. So I've seen this screwed up with alarms, where if you have this backwards, you're either going to have an alarm locked in that's not supposed to be, or you're going to alarm on the opposite status, and it might not come in. The alarm might not come in when the actual condition's happening, and you could be totally, and that's not a good thing. So it's just, you have to understand, and it gets confusing. So you have to say it out loud so it makes sense, and always read documentation that says, is this normally open or normally closed, so you set up your alarms correctly in SCADA and in the PLC as well.